Hi everyone, I'm Joe O'Connor. I'm head of machine learning at Transition Zero. I'm going to talk about our upcoming open dataset of solar PV assets. So Lucas already introduced Transition Zero. The ML team at Transition Zero basically feeds our data and modeling platform with energy data sets. So we need lots of globally distributed data on at as high resolution as possible to enable as many use cases for our models as possible. And this is where our solar dataset, solar project comes from. So this is one of the data gaps that we tried to fill. This red bar is the progress of total solar PV capacity in the world, and the blue bar is basically the best available open asset level data set of solar PV. There's a relatively large gap, and yeah, you can basically pick 2 out of 3. Your data set is relatively up to date. We can already see that this IRENA data set is lagging behind by over a year. It is granular. It describes individual assets and their locations, and it is complete. So Global Energy Monitor, other asset level providers don't have a complete view of everything that is out there. And so the way that we're filling this gap is with machine learning using open data. Our inputs are images, open Sentinel-2 satellite imagery, geometries from OpenStreetMap, and then some modeling, so gratuitous neural network diagram. So we're using deep semantic segmentation to build sort of pixel-wise maps of this is a solar panel, this is not, and then applying and deploying them over the entire world. So it's just a quick showcase of some of the things that we found. China likes to build solar farms in the mountains these days. They're increasingly common. This one's not that clear to see, but it's definitely a very large solar farm. Some places also like to build them on the water. This isn't actually a river, it's a lake. And so this map shows actually a sample, I think about 10% of our total data set. There's lots and lots of stuff in China, as you might imagine. What else can we do? So we don't only provide the locations and sizes of things, we're also able to use our model, apply our model backwards in time to estimate the construction date of each of the facilities in the data set, or a large number of facilities in our data set, and provide estimated construction dates and therefore infer estimated grid connection dates. And we're also able to estimate capacities, so you can guess the capacity of a solar farm from its size. You can go a little bit further, and we put quite a lot of time into doing a bit better than just estimating it from its size. You can observe some sort of country level effects that tell you that some countries are likely to build denser solar farms than others, and so do slightly better. And so this graph is, there's a few things going on, but it sort of summarizes our total results. This is capacity on the detected capacity on the y-axis, or capacity coverage on the y-axis, and plant size on the x-axis. And so what this basically shows is that we find similar amounts of large plants to existing open data providers, but we have this sort of unique capability to find lots and lots and lots of smaller plants. So we go down to about 1 megawatt, so still utility scale, but we find much more than anyone else can because there's so many of them. And so just to wrap up, we are about to release this data set under an open data license, not quite there yet. The data will also be integrated into the Transition Zero platform, and also in Global Energy Monitor, who we've seen a few times. We're sharing the data with them so they can include it in future releases of their solar power tracker. So yeah, please watch these spaces for the release if you want to use the data. Thank you.